Welcome to section 1.4, Introduction to Identities. A trigonometric identity is an equation that involves trigonometric functions and holds true for all values within the domain where the expressions are defined. These identities serve as essential tools in trigonometry, allowing us to evaluate functions, simplify expressions, verify relationships, and solve equations efficiently. There are 3 objectives in this section. Let's look at the first one. Find the value of a trigonometric function given the value of its reciprocal. Since trigonometric functions have reciprocal relationships, if we know the value of one function, we can determine the value of its reciprocal function using the identities. So we know cosecant of theta equals 1 over the sine of theta. Secant theta equals 1 over the cosine theta. Cotangent theta equals 1 over tan theta. Sine of theta equals 1 over cosecant theta. Cosine theta equals 1 over secant theta. Tan theta equals 1 over cotangent theta. So here are some directions to help us find a trigonometric function given its reciprocal. First, we're going to identify the given reciprocal function. Then we will use the reciprocal identity to rewrite it in terms of sine, cosine, or tangent. Then we'll take the reciprocal of the given value. And then number 4, check the quadrant to determine the correct sign. So sometimes questions will tell you that your value is only in quadrant 2 or only in quadrant 4. And then from there, you can then determine whether your answer should be negative or positive. So let's do some exercises together. Our directions tell us to use the reciprocal identities to find the following. If sine of theta equals negative 2 over 3, find cosecant theta. Well, according to the reciprocal relationships, cosecant of theta equals 1 over sine of theta. We know that sine of theta is negative 2/3. So 1 divided by negative 2/3 is negative 3 over 2. So the cosecant theta equals negative 3 over 2. Number 2, if cosine theta equals 3 over 5, find secant theta. Well, we know, according to the reciprocal identities, that secant theta equals 1 over cosine theta. If cosine theta equals 3/5, then secant theta equals 5 over 3. Number 3, if tan theta equals 1/8, find cotangent theta. Well, cotangent theta equals 1 over tan theta. If tan theta equals 1/8, then cotangent theta equals 8. Number 4, if cosecant theta equals 4 over 3, find sine of theta. Well, sine of theta equals 1 over cosecant theta. If cosecant theta equals 4 over 3, then 1 divided by 4 over 3 is 3 over 4. If secant theta equals 7 over 3, find cosine theta. Well, according to the reciprocal identities, cosine theta equals 1 over secant theta. Secant theta equals 7 over 3. So cosine theta equals 3/7. Number 6, if cotangent theta equals -7/5, find tan of theta. Well, tan of theta equals 1/cotangent theta. If cotangent theta equals -7/5, then tan theta is -5/7. Alrighty. Now let's look at the second objective. Find the ratio identity of a given trigonometric function. Ratio identities express trigonometric functions in terms of the fundamental relationships between sine, cosine, and tangent. These identities help simplify expressions and solve equations by rewriting functions in alternative forms. The two primary ratio identities are tan theta equals sine over cosine, and cotangent theta equals cosine over sine. So here are some steps to help you determine the ratio identity for a given function. Number 1, you'll identify the function you're working with, whether it's tangent, cotangent, secant, cosecant. Number 2, you'll use the appropriate ratio identities to express it in terms of sine and cosine. And then number 3, you'll substitute known values if applicable to simplify the expression. So for our exercises here, we're asked to use the ratio identities to find the following. So if cosine theta equals -3/5 and sine theta equals 4/5, find tangent and cotangent. So first, let's find tangent. So tan theta, according to the ratio identity, says that sine theta divided by cosine theta is its ratio identity. Well, we know that sine theta is 4/5 and cosine theta is -3/5. If we were to divide these two ratios, we would get -4/3. So the tan of theta is -4/3. Now we can find cotangent, and there are two ways that we can solve it based off of the information we have just learned. So the first way we could do it is to use the ratio identities. So cotangent theta is cosine theta over sine theta. Cosine theta is -3/5. Sine theta is 4/5. When we divide these two ratios, we get -3/4. The second way is to use the reciprocal identities, where cotangent theta is 1/tan theta. We know that tan theta is -4/3. So 1 divided by -4/3 would be -3/4. Both identities get you to the correct answer. Okay, let's do the next one. If sine theta equals 5/7, find sine squared theta. Well, sine squared theta is the same thing as sine theta squared. They mean the same thing. Both of these expressions are equivalent. So if sine theta is 5/7, then 5/7 can be substituted for sine theta. So now we have 5/7 squared. 5/7 squared will get us 25. Let's rewrite that part. 25 over 49. So sine squared theta is 25 over 49. Number 9. If tan theta equals 4 over 3, find tan cubed theta. So similarly, tan cubed theta equals tan theta cubed. Since we know that tan theta is 4 over 3, we can substitute that for tan. So we will be evaluating 4 over 3 cubed, which equals 64 over 27. All right, our third objective. Solve problems involving Pythagorean identities. Pythagorean identities are fundamental trigonometric equations derived from the Pythagorean theorem. These identities help simplify expressions, verify equations, and solve trigonometric problems. The three main Pythagorean identities are 1. Cosine squared theta plus sine squared theta equals 1. The second one, 1 plus tan squared theta equals secant squared theta. And 3, 1 plus cotangent squared theta equals cosecant squared theta. All of the identities on the right side here are all derived from the first Pythagorean identity. Okay, so to get sine squared theta, you would subtract cosine squared theta to the other side, which is what we would get here. Then to get rid of the square, we would then take the square root of both sides, which is then what we get here on the second row. Then you would do same steps to find cosine squared theta and cosine. So these identities hold for all values of x where the functions are defined. So when solving problems with Pythagorean identities, you may need to find the missing function values given in one trigonometric value, then rewrite the expressions to simplify or prove identities, and then solve the trigonometric equations by substituting in values. So in our exercise here, it states that if sine theta equals -1/3 and theta terminates in quadrant 3, we are asked to find cosine theta and tan theta. Okay. Well, we know the theta terminates in quadrant 3. So if we use our acronym, all students take calculus, in quadrant 3, only tangent is positive. So that means our value for cosine is going to be negative and our value for tangent is going to be positive. Okay. We know that sine theta equals -1/3. That was given to us. Okay. So let's find cosine theta. So cosine theta, if we use one of our Pythagorean identities, tells us that cosine theta equals plus or minus the square root of 1 minus sine squared theta. Since we know that cosine theta must be negative, we can rewrite this identity with just the negative sign. Okay? Because we're only taking the negative since cosine is negative in quadrant 3. So let's evaluate the right side. So we know sine squared theta is going to be -1/3 squared all under the square root. So then we can simplify negative 1/3 squared, which gets us 1/9. And then 1 minus 1/9 is 8/9. Okay. When we simplify this square root, we can break the square root up between the numerator and denominator, and then simplify each one individually. So the square root of 8 would be 2 square root 2, and the square root of 9 would be 3. Okay, so that means the cosine of theta equals negative 2 square root 2 over 3. Okay, so now that we have found cosine, let's find tangent. Okay, well, we know that tangent equals sine of theta over cosine of theta. We know sine theta is negative 1/3. We know cosine theta is negative 2 square root 2 over 3. So if we were to simplify this ratio, we would get 1 over 2 square root 2. To get the square root out of the denominator, we'll multiply the numerator and denominator by the square root of 2. When we multiply across, we would get square root 2 over 4. Okay, so that means the tan of theta is square root 2 over 4. Now there are other identities that we could have used to help us get tangent. All right, but I recommend utilizing the identities that involve values you already have been given. Okay. All right. Exercise 11. If cosine theta equals negative 5/13 and theta terminates in quadrant 2, find the remaining trigonometric ratios of theta. Well, we are given that cosine equals negative 5/13. Theta terminates in quadrant 2. So that means theta is going to be positive for sine and cosecant, but negative for all other trig functions. And then we know we need to find all 6 trigonometric ratios. Okay, so since we have cosine, let's start working with identities that give us the other trigonometric ratios relating to cosine. So let's first start off with the reciprocal relationship. So we know cosine theta is negative 5/13. So that means secant theta will be 1 over cosine theta, which equals 1 over negative 5/13, which equals negative 13/5. Okay, so we found one trigonometric function. We have 2, we have cosine and secant, we have 4 more to go. Now let us find sine theta. We can use one of the Pythagorean identities where we have plus or minus the square root of 1 minus cosine squared theta. I chose this one because I know what cosine is, so I'll use the identity that allows me to get sine using the value of cosine. Since I'm in the second quadrant, I know that my value is going to be positive, okay? Because sine is positive in the second quadrant. So I don't need plus or minus because I know it's just going to be plus, positive. All right, so I have 1 minus cosine squared, which would be negative 5 over 13 squared. It's all under the square root 2. All right. Negative 5 over 13 squared is 25 over 169. 1 minus 169 is 144 over 169. I can split the square root between the numerator and the denominator. The square root of 144 is 12. The square root of 169 is 13. So the sine of theta equals 12 over 13. Okay. Since I know the sine of theta, I can find the tangent of theta. The tangent of theta is the sine of theta, which we just found, over the cosine theta, which was given. So the sine of theta is 12 over 13. The cosine of theta is negative 5 over 13. So that means the tan of theta will be 12 over 5, and it will be negative. Okay. So we know the tangent of theta, so we can find the cotangent of theta using the reciprocal identity, because we know the cotangent of theta is 1 over the tan of theta. So that will be 1 over negative 12 over 5, which equals negative 5 over 12, the reciprocal. Okay. And then our last trig function we need to find is the cosecant of theta. The cosecant of theta is equal to 1 over the sine of theta, which will equal 1 over 12 over 13, which equals 13 over 12. And it is positive. Okay. All right. So we have all 6 trig functions. We have all 6 of them. All right. So we were given the cosine of theta, which was negative 5 over 13. The secant of theta, which is negative 13 over 5. The sine of theta, which is 12 over 13. The tangent of theta, which was negative 12 over 5. The cotangent of theta, which was negative 5 over 12. And the cosecant of theta, which is 13 over 12. Since theta terminates in quadrant 2, the only 2 trigonometric functions that will be positive will be sine and cosecant. All right, that concludes presentation for 1.4.